Welcome, Manisha madam.
Manisha ma'am, unmute yourself.
Okay.
Welcome, Manisha madam.
Thank you so much, ma'am. Thank you. Am I audible?
Yes, you are.
Yeah. Shall I start, ma'am?
Yeah, you can start, madam.
Okay. Okay, thank you so much, madam, for for the kind words. A very warm good afternoon to all the delegates. Before starting my session, I would like to, thank Dr. Hardas ma'am, HOD Department of Applied Physics in Priyadarshini College of Engineering, Dr. Suvarna Savde, coordinator for this workshop for this STTP on updations in teaching, learning techniques and research, for giving me an opportunity to present some ideas in front of all of you in this STTP. I would also like to congratulate the entire organizing team for successfully organizing this STTP, which is very apt in this current scenario of teaching and research. So, before starting, I would like to start my presentation. You just let me know whether it is visible to you, because I'm sharing my screen through computer. Yeah, just a minute. Please let me know if it is visible to you.
Yes, it is, madam.
Yeah, is
It's
it
visible.
visible? Ma'am, is it visible
Yes,
to all
it
of
is
you?
visible. It is visible, madam.
Is it visible, ma'am?
Yes, yes. Yes, it is visible.
Yes ma'am, it is visible.
Okay, and I'm audible as well?
Yes, you are audible, madam.
Yeah, please let me know whether I'm audible.
Yes madam,
Yes, you are audible.
Yes, Aditi ma'am?
Yes madam, you are audible. Ma'am, you are audible.
Okay. So good afternoon, everyone. Today's my topic for presentation is it is an approach of modeling of a chemical reaction based on experimental data. Basically, modeling of any phenomena or activity. Just a minute. I think. Yes, basically modeling of any phenomena or activity, it means establishing an analytical relationship amongst the causes and responses of any activity or a phenomena. Causes are basically they are the inputs for the activity and responses are the outputs for the activity. Now it is stated that it could be any activity or phenomena uh, like if we consider the mathematical modeling, then we can say that mathematical modeling, I mean, it is used to, it is the use of a mathematics to describe the real world phenomena. Real world phenomena is any activity which is carried out. Now, basically, now that we all know, I mean, the mathematical modeling because we are listening to it since so many days or so many years. Here we may say that the use of mathematics to describe the real world phenomena or activity or to investigate the important questions about the observed world, to explain the real world phenomena, to test our ideas, whatever ideas we have in our mind, or to make some predictions about the real world. This is basically what the mathematical modeling is. Now, if we consider the real world mean it is any activity or any phenomena coming under the domain of, say, engineering, or physics, or physiology, or ecology, wildlife, even wildlife management, or chemistry, or economics, or sports, or so and so forth. Whatever topic you choose, we can say that activity or phenomena coming under that topic is the real world, that is we refer to it. Now if we let us consider some examples of real world. Now like teaching learning process which we are all into, then an example of digging of soil in the garden or taking off an aeroplane from the ground. Now, if we consider these examples, then in these cases, taking off an aeroplane from the ground, it is usually considered as a phenomena either scientific or belonging to applied science or to engineering domain. Whereas teaching learning process or digging of soil in the garden is usually not considered as a phenomena of say science or engineering domain, but this is considered as a phenomena belonging to man machine system. So in case of, for example, digging of soil in the garden, in this case, say, let us consider a person who is digging the soil in a garden for a certain area. In that case, it is necessary to establish among, I mean, whatever the causes of this activity is or the outputs of the activity is, and if we consider digging of soil in the garden as an activity, then in this context we can have namely three responses like human energy input, amount of soil that has been dug by that person, then precision with which the activity is performed, that is the quality of that performance, that also is considered. One more example we can take is like a cricket strike. We might be interested in predicting the effects of the higher players' salaries on the long-term health of the cricket industry. So all of these questions, they come under the real world questions. Uh, Whenever if we, I mean, we wish to maximize or minimize certain responses, then we have to adopt a certain techniques which is called as optimization technique. Now, for any system or any phenomena or activity, it has basically four sets of variables like system constants, system independent variables, system dependent variables, and extraneous variables. In this case, inputs are considered as causes or the independent variables of the activity. Outputs or responses are considered as the dependent variables of the activity, and the extraneous variables are those inputs which do affect the activity, but it is not possible to measure them. I mean, it indirectly affects the activity, but we cannot measure it, we cannot observe it experimentally. And but these can be, represented numerically. These can be represented numerically considering some constants. However, using the concept of weightages, their numerical values can be ascertained. And mathematical modeling is to establish an analytical relationship between the causes and responses so that we can decide necessary inputs either to minimize or to maximize some of the outputs of that activity. So mathematical modeling basically is often used in place of experiments when such experiments are too large. I mean, they require lots of equipment, lots of things, or they are quite heavy, quite large experiments. In that case, we can represent that particular activity or phenomena through mathematical modeling. Or otherwise, if the experiment is too expensive, like in case of rocket science and all, where the experiments are so expensive that not have a trial and error basis of experiments. So in that case, we can also represent that activity through mathematical modeling. Or there are certain experiments which are very dangerous, like in case of nuclear reactors and all. There also we can use the mathematical model. Or there are certain the activities or experiments which are too time consuming, like in case of say agricultural activity. It takes years and years for a seed to sow and get it converted into a plant and to study its nature or behavior. For such systems or for such activities, we can represent these systems through mathematical modeling. This also can be useful in what if studies, like if we want to investigate the use of some pathogens to control an insect population, then also we can have a mathematical modeling for that particular system. For example, during this corona pandemic, what we have seen is that the scientists, they made certain predictions which are based on the mathematical modeling of the previous data for this deadly diseases. So this modeling or mathematical modeling can be used to represent such activity or such phenomena, or we can say that it is nowadays a modern tool for scientific investigation. But then the main challenge in mathematical modeling is not to produce the most descriptive model, but the main challenge is to produce the simplest possible model, because we want to have all the major features of the activity in that particular model. But it should be the simplest one so that anybody can use it, can apply it, can implement it, and can predict properly or correctly using that particular mathematical model. Now, there are different types of mathematical modeling or various approaches to the mathematical modeling, and they are like logic-based approach, experimental data-based approach, then field data-based approach, then based on the mathematical modeling based on data generated by evaluating a particular design, or a model based on data gathered by earlier investigators. So these are certain, the types or approaches to the mathematical modeling. Now let us discuss how modeling of a chemical reaction on experimental data can be established. Now, in case of modeling of a chemical reaction, although the logic-based modeling is also possible, and this is normally discussed in physical chemistry or in case of kinetics of a chemical reaction. However, that being rather complicated at some times, fairly abstract approach of applying laws of classical mechanics like Lagrangian formulation or Euler formulation, or the combination of both are used, then for any chemical reaction which is fairly new, or the experimental data-based model approach is, it has to be a straightforward, it should be easy to understand, it should be easy to implement, as well as outcome wise, it is equally important as it would be by logic based approach. So in this lecture, therefore it is proposed to elaborate this approach and to demonstrate its application to the chemical reaction studied during my doctoral research. Now, there are various steps which has to be followed while formulating a model. Like in this case, the first step involved is to identify all the causes and the responses.
Manisha ma'am, you are not audible.
Okay, am I audible now?
Yes, you are.
Okay. Okay. So, in this lecture, therefore, it is proposed to elaborate the approach of mathematical modeling and to demonstrate its application for a chemical reaction. Now, this includes the various steps which has to be followed during formulation of a model. The first step is to identify all the causes and effects of the activity, that is, the phenomena which we are considering for our formulation of a mathematical model by qualitative physics of that activity. Then the second step, once we list out all the causes and effects of the phenomena, the second step is to reduce the number of causes. And this is done by a method which is called as dimensional analysis. After doing this, the third step is test planning, and this includes the test envelope or test points, test sequence and experimental plan. What does it mean is we have to plan our experiment first. We have to find out the points at which we have to take the observations, the sequence, like whether we want to take the observation while increasing a particular cause or while decreasing a particular cause of the activity, and then only we can proceed with our experimentation and we can get the observations. Then the fourth step includes to vary all the independent pi terms. Independent pi terms is which we have defined as the causes of our activity or the phenomena. So we have to vary all those independent pi terms through the experimental setup. Like if we want to change the temperature during the experimentation, then we can do it. If we want to vary the percentage composition of the reactors, then also that we can do during the experimental setup. So that is the fourth step that is involved. And the fifth step is we have to gather all the data regarding these independent and dependent pi terms by observations, by measurement, by performing that particular experiment. And based on this data which is generated during the experimentation, we have to establish the relationship between the causes and effects of that activity, of that phenomena. This is what we have to do while formulating a mathematical model. So, any real world phenomena can be converted into model world in the form of mathematical model, whose interpretation and testing gives an idea about the real world phenomena. Now, model gives us the solution of the problem in terms of numerical values, and these results, they can be validated. They have to be validated for their performances. So the things should not be multiplied without any fair reason. In short, the 5 stages of modeling from identifying a problem to getting its solution is the first thing is to ask the question. Ask the question means find out the problem, formulate or form the hypothesis. Then we have to select the modeling approach, like whether we have to go for a logic-based model or experimental database model or field database model, etc. Then we have to gather the data and formulate the model. Then we have to solve that model. We have to see whether the answers or the results that we get with the help of that model is correct or not. That we have to validate if it is possible, and then only we can get the answer for the question that has been asked. The first hypothesis that we have made during our the method. So, but we may say that for formulating an accurate model, we may require complete mix of skills, that is knowledge of the system or the phenomena which is under investigation. Then we need to have the knowledge of model formulation. We need to have the knowledge of model program. We need to have the data collection skills as well. Whatever data we collect during our experimentation, that has to be also done properly. And we also require the statistical skills as well. That is input data representation. We have to represent the data properly. This is also required. Thus, formulating a model, it requires to carry out an experiment by applying proper theory behind it and then computing the data that has been obtained. So mathematical modeling, it complements, but it does not replace the theory and experimentation in our scientific research work. It complements both the things. It validates the theoretical and the experimental part, but it cannot replace. We cannot replace completely the experiment or theoretical part which is there in our scientific research work. Now, during my doctoral research on synthesis, spectral, thermal and magnetic studies of some coordination polymers, I synthesized the oxaloyl carboxymethyl cellulose Mn2 coordination polymers, and this has been synthesized by refluxing 10 grams of oxaloyl carboxymethyl cellulose and 100 ml of 0.2 molar aqueous manganese acetate at 120 degrees Celsius in an oil bath for 2 hours. The inorganic polymer or the coordination polymer that was obtained, it was then cooled, it filtered and washed with hot water to remove any metal acetate or the unreacted ligand which might be there in the product. Now, in the present study, we have used the thermogravimetric analysis of the synthesized product, that is Mn2 oxaloyl methyl carboxymethyl cellulose. It has been undertaken, and it has been observed that there is no sharp wet loss in our thermogram of this particular polymer, and which indicates that the product that we have obtained, that I have obtained during my work, is polymeric in nature. This has been observed. Now the TG curve, that is the thermogravimetric curve of Mn2 OCMC, that is manganese to oxaloyl carboxymethyl cellulose polymer, it shows no mass loss up to 140 degrees Celsius, which is because of the absence of the water of crystallization. Then there has been a mass loss of around 9.51% between 140 to 200 degrees Celsius, and this shows the presence of 2 coordinator water molecules in the polymer. Then after 240 degrees Celsius, it shows a gradual decrease in the mass up to 700 degrees Celsius, which may be due to the decomposition of the ligand attached to the metal ion, and thereafter there was no further mass loss has been observed, indicating that the stable metal oxide has been formed. And during this process, the decomposition temperature that has been found was around 400 degrees Celsius, and the rate of heating that was used for this thermogrammetric study is 10 degrees Celsius per minute. Then these are the data that was obtained during the thermogrammetric study. That is, and this data was used for formulation of the mathematical model in this particular work. The various independent and dependent variables were identified, like weight of the auxiliary carboxymethyl cellulose that has taken during the formation of the product, then the weight of Mn acetate, temperature of the reaction, time taken for the reaction, then the weight of sample taken for thermogrammetric study, heating temperature, at what temperature that sample has been heated, then percentage weight loss due to decomposition, rate of heating in degrees Celsius per minute, then time of heating, decomposition temperature, etc. All these data was tabulated, all these variables were identified, and the data obtained was tabulated in this table. Now now since we have so many data or so many independent variables or so many the variables that used during the experimentation, each independent variable, the next step is to reduce the number of independent variables by clubbing them in together so that we could get the dimensionless quantity. And this method is called as dimensional analysis that I have said earlier. In this dimensional analysis, what is done is the data or the independent variables that we have used during our observations, those variables are so clubbed together that the final term that we get is dimensionless, that is without any unit. So it has been called as the pi term, and pi term has no unit. So in this case, we have formulated that the dimensional analysis has been done and the experimental data has been converted or modified into 3 pi terms. That is pi 1. Pi 1 is equal to weight of OCMC in grams divided of weight of Mn acetate in grams. Then pi 2 is temperature of reaction into heating temperature in degrees Celsius divided by rate of heating in degrees Celsius per minute into time of heating in minutes whole square. To have a dimensionless quantity, we can do this. We can either square this or we can do this kind of activity in this dimensionless analysis. The third pi term that we get is pi 3. It is time for reaction, that is in seconds, into acceleration due to gravity. We can use any constant to get the dimensionless quantity divided by velocity of light in meter per second. This is also constant, so this can also be used. And the last, that is pi 4, is the percentage. Pi 4 is the dependent pi term and it is the percentage weight loss due to decomposition. Now, these are the computed values for all the pi terms based on the earlier dimensionless analysis that we have carried out. We have computed the modified, we have found out this modified data and computed all the values for the different pi terms. That is pi 1, pi 2, pi 3 and the pi 4, that is the percentage weight loss due to decomposition. Here it is called as dV1. Now this data for independent and dependent parameters of the chemical reaction gathered during the experimentation needs to be correlated quantitatively, and this is nothing but the formulation of mathematical model. So each dependent pi term is assumed to be the function of available independent pi terms, and the development for dependent pi term, that is pi 4, for this pi 4, we can assume that pi 4 is a function of pi 1, pi 2 and pi 3. And a probable exact mathematical form for this particular phenomena, it could be pi 4 is equal to K1. K1 is the constant for this particular equation. K1 into pi 1 raised to A1 into pi 2 raised to B1 into pi 3 raised to C1. Now there are 4 unknown terms in this equation, that is K1. We don't know the value for K1, A1, B1 and C1. We don't have the values for these four unknown parameters in this equation. Now to get the values of these unknown terms, we need four sets of values for pi 1, pi 2, pi 3 and pi 4. But during experimentation, we have 41 observations. And if any arbitrary value of any observation are used for computation, then it may not result or it may not give us any one best unique solution representing the best fit unit curve for the remaining sets of values. So for this reason, it was decided to solve this problem by curve fitting technique. And and to follow this method, it is necessary to have the equation in the form as z is equal to a plus b into x plus c into y plus d into z plus so on and so forth. And this is known as an exponential form of the model. With this form, it becomes possible for us to interpret the influence of a single term or the independent variable in an explicit manner on the dependent term. So by taking log of both the sides of equation 1 that we have seen in the earlier slide, we can get log of pi 4 is equal to log k1 plus a1 into log of pi 1 plus b1 into log of pi 2 plus c1 into log of pi 3. And using this, just to simplify this, we consider log of pi 4 as z1, log of k1 as k1 dash, log of pi 1 as a, log of pi 2 as b, log of pi 3 as c. So, and hence the equation 1, it can be written as z1 is equal to k1 dash plus a1 into a plus b1 into b plus c1 into c, the exponential form of model that we have seen earlier. So this equation is a regression equation of z on ABC, and to determine the regression hyperplane, we determine a1, b1, c1 in equation 2. So that summation z1, we have to get the summation of all those terms in the table, because we have 41 observations, total 41 observations in our table. So summation z1 is equal to n is the number of observations or the number of sets of values, n into k1 dash plus a1 into summation a plus b1 into summation b plus c1 into summation c. And if we multiply this equation by a, b, c, we can get another three equations like summation z1 into a is equal to k1 dash into summation a plus a1 into summation a into a plus b1 into summation b into a plus c1 into summation c into a. Then another equation, if we multiply it by b, we get summation z1 into b plus k1 dash into summation b plus a1 into summation a into b plus b1 into summation b into b plus c1 into summation c into b. And if we multiply the same equation by c, we get summation z1 into c is equal to summation k1 dash into summation c plus a1 into summation a into c plus b1 into summation b into c plus c1 into summation c into c. So these equations, these four equations we can get. After substituting these values in equation 3, we get four equations which are to be solved simultaneously. And to get the values of for k1 dash, a1, b1 and c1, which are unknown parameters, we don't know their values. For this, we have to use the, we can get the use of Matlab, and using the matrix method for solving these equations by using Matlab, we can get the values for k1 dash, a1 and c1. So for example, consider A is equal to 4 into 4 by 4 matrix of multipliers of k1 dash, a1, b1 and c1. Then B is equal to 4 by 1 matrix of the terms on left hand side, and C is equal to 4 by 1 matrix of the solutions or the values of k1 dash, a1, b1 and c1. Now the values of the terms on left hand side of equation 3 and the multipliers of k1 dash, a1, b1 and c1, they are calculated and they are tabulated in this table, and the summations have been found out using simple our Excel sheet. Now, this is the MATLAB program for our particular model formulation or particular matrix. So, in our case, A is equal to all these values which are there on the left hand side. Then capital A is equal to the values 4 by 4 matrix on the right hand side. B is the values on the left hand side, and that is written there in the MATLAB. And then if we get the, if we have the formula of inverse A into B, we get the solution for multiplication of this 4 by 4 matrix and 4 by 1 matrix. And then our answers are minus 0.6765, 0.1438, 2.0978 and 0.6371. And for this we have to take the antilog of K1 dash and we get the solution. So the model for pi 4, after substituting these values in our model, we get pi 4 is equal to 0.2106 into pi 1 raised to 0.1438 into pi 2 raised to 2.0978 into pi 3 raised to 0.6371. These are the unknown variables that we have got using the MATLAB programming. So K1 dash is equal to 0.2106, then A1 is 0.1438, B1 is 2.0978 and C1 is 0.6371. All the 4 values are obtained, and using this, by putting these values in the formula, this is the model for our the phenomena or activity or the problem under study, and that is pi 4 is equal to 0.2106 into pi 1 raised to 0.1438 into pi 2 raised to 2.0978 into pi 3 raised to 0.6371. Now this lecture covers all the features of outcome from the application of proposed experimentation. And the analysis methodology to the experimental setup. Now the quantitative analysis, it comprises of the checking the reliability of the model, checking the sensitivity of the model and optimization of the model. Now the reliability of the model is evaluated on the basis, or it has a particular set of procedure for checking the reliability of the model. For this, we have to substitute the known values of independent variables in our mathematical model. Whatever mathematical model we have found out, for checking its reliability, we have to substitute the values in this mathematical form. Then we have to calculate the values for dependent variables. Then we have to find the error. We have to calculate the reliability of the model by calculating the mean error. And this mean error is calculated by using the formula reliability is equal to 100 minus percentage mean error, where percentage mean error is equal to summation x1 f1 by summation f1. Summation x1 f1 is the summation of the product for percentage of error and frequency of occurrence of the error. And summation f1 is the summation of frequency of error occurrence. Now for available mathematical model, the known value of independent variable is substituted so that the values of independent variables, which is known as calculated values of dependent variables, can be found out. And the error in the calculated value of dependent variable and observed value of dependent variable, it can be ascertained or it can be found out. And for this, it is necessary to subtract the calculated value from observed value for dependent variable. And once the error is calculated, then the reliability of the model, it can be found out using this formula, that is 100 minus percentage mean error. So using this, the percentage error and the frequency of occurrence of the error have been found out, and it has been observed that the reliability of the model is minus 180.24. Now reliability of minus 180.24 is not at all acceptable, and hence it is necessary to change the mathematical form of this dimensional equation. Thus the product of pi 1, pi 2 and pi 3 is taken. Since these are dimensionless activity, we can take the product of all of them, and accordingly the products were taken and it has been tabulated in this table, pi1 into pi1, pi2 into pi3, and against the percentage weight loss due to decomposition, then its log is taken, log of pi1, pi2 and pi3, and the log of percentage weight loss due to decomposition was taken in this table. And then its graphical representation is done like this. The log of pi1, pi2 and the log of product of pi1, pi2, pi3 on x-axis and log of percentage weight loss on y-axis. So it has been observed that this graph, it indicates the whole phenomena, and the entire phenomena, it has been observed that it has 4 phases depending on the number of shape changes of the complete activity or complete graph. In this case we can say. So in this case, AB from point A to point B, it is slight exponential, it shows slight exponential decay. Then from point B to C, it is almost constant. If the variation is not there, it is almost constant. From C to D, it is rather high exponential decay, we can say. And from D to E, the exponential decay is there, but with a very small rate. But it can be reduced, the entire model, it can be reduced to, the entire model should have 4 models, because it has 4 phases like AB, BC, CD and DE. But it can be reduced to 2 models, that is one for AB and BC and the other for CD and DE. And accordingly, 2 figures can be obtained corresponding to phases AB and BC, as shown in this first figure, and corresponding to the phases CD and DE as shown in the second figure. And it has been observed that these models, the phases, they can be represented by the the equation 9, and it is y is equal to 12.96 plus 6 x plus 16 points. And if we put the values of x and y in these equations, it has been observed that the reliability of these models is around 101.52%, and for the second phase, the reliability of the model is around 100.52%. Now, after finding out the reliability of the model, the sensitivity analysis has to be done. Now, this sensitivity analysis is carried out by introducing the percentage change in each independent pi term, and we can see its effect on the dependent pi term. Like percentage change, maybe a change of plus minus 10% is introduced in the individual pi terms independently, and the effect of change in on the independent pi term on the dependent pi term is found out. So it has been observed that the in the established model, when a total of around 20% change was introduced in the independent pi term, pi 2, then the model shows the sensitivity of 9.886693. For pi 1, it is 0.0213, and for pi 3, it is 0.000094. And hence, on the basis of this, we can say that pi 2 term is the most sensitive pi term, and pi 3 term is the least sensitive pi term. And the sensitivity of these different pi 1, pi 2 and pi 3 terms in decreasing order, it can be pi 2 is more sensitive than pi 1, and the least sensitive is the pi 3 term. So pi 2 has greater sensitivity than pi 1 than pi 3. This can be obtained by, this is what the sensitivity analysis is. The basic aim of establishing the mathematical model is not to simulate the phenomena, but also to find out the best set of independent variables as well. This will result in maximization or minimization of the our objective function. Now, for for optimization of the model, our ultimate aim, ultimate objective is to minimize the percentage weight loss. So, for this, we need to apply the constraints to this problem, and certain range of independent terms has been decided, which has been which has a minimum and maximum value. So the basic aim of establishing a mathematical model is not only to simulate the phenomena but also to find out the best set of independent variables. Now, in fact, the model is in a non-linear form. Hence, for the purpose of optimization of the model, the same has to be converted into a linear form. And this is done by taking a log of both the sides, which we have done earlier also, and taking logarithm of both the sides, we can convert the model into a linear form. And to minimize the linear function, we can use linear programming techniques. Now, for optimization, certain range of independent terms has to be decided, and which will have certain minimum and maximum values. And this range which is decided is the constraint for the problem. And in this case, in my study, the constraint was for pi1, maximum range is 2.04 and minimum is 2.04. For pi2, maximum constraint or maximum range is 367.38906 and minimum is 133.24, and for pi3 it is maximum is 0.0002352 and minimum is also 0.0002352. And to solve the linear programming problem, it is solved with the help of MS Solver, which is available in Microsoft Excel. And the minimum value of Z and the set of independent variables to achieve this minimum weight loss is obtained. And then we have to take the antilog of Z, X1, X2 and X3, and after solving the problem, actually the corresponding values of independent terms are obtained by taking the antilog. Or for Z, the value which is obtained was 32.60. For log of pi1, it is 0.309804. For log of pi2, 2.14643. And log of pi3, it is minus 3.62856. Now, there are different forms of models. Like in the earlier discussion, we have combined the three independent quantities, that is pi1, pi2 and pi3, by taking their straight products. We have considered only the multiplication of pi1 into pi2 into pi3, that's all. But apart from that, since all the pi terms are the dimensionless activity, we can we can treat them in different ways as well. So we can also have another form of the model, like pi4 is equal to pi1 into pi2 divided by pi3, or pi4 is equal to pi1 into pi3 by pi2, or pi4 is equal to pi2 into pi3 by pi1. So we may think, why not other possible combination of these pi terms can be considered. But they would be simply reciprocals of these, and then there is no point in considering the reciprocals of these, because it may give just the functionally inverse model. Now, after putting the values of pi1, pi2 and pi3 in the above equations and solving them, a graph was plotted between the left-hand side on y-axis and right-hand side on x-axis. That is pi1, pi2 by pi3 on x-axis in the first graph, and percentage weight loss on the y-axis. And we can observe all of them have almost the similar shape. Obviously, the puzzle would be if we get so many graphic plots like these, which one out of these should be chosen? So the hierarchy of graphic plot would be as under. Now, the graphic plot is parallel to y-axis. The graphic plot is parallel to x-axis. and the graphic plot is parallel to or it is a straight line with equation y is equal to mx plus c, having the slope m and intercept c. Or there is another possibility, that is the graphic plot with some peaks, that is two peaks, then the graphic plot may appear like this, the graph with two peaks, or if it has three peaks, then it may look like this, the graphs having three peaks. So then one with which would have minimum number of peaks has to be chosen. It has to be selected, the one which has the lowest number of peaks. If you get these type of graphs, then in this case the one which has the lowest number of peaks has to be chosen. And the corresponding model would be the polynomial form as under pi4 is equal to a0 plus a1x plus a2x raised to 2 plus a3x raised to 3 plus a4x raised to 4. In case of graphic plot with two peaks, wherein x is some combination of pi1, pi2 and pi3. Now at time, an interesting situation it may come across. That is, for all possible combinations of independent pi terms, the number of peaks are same. Say for example, if we get two peaks in all types of graphs, then which of them should be selected or should be used for formulation of our mathematical model? Then in this, under these circumstances, it is necessary to choose the graph having the minimum average height of the peaks. And it has to be finally chosen as it is the one having the simplest variation. It has the simplest variation. So this has to be chosen. And there is yet another form of model that is known as response surface model, which is called as RSM. Popularly it is called as RSM model, and alternatively this is a 3D mapping of the experimental data. Now the entire experimental data is to be mapped in 3D space. So obviously the axis of reference would be OX or X, Y and Z. In this present study, there are in all three independent pi terms, that is pi1, pi2 and pi3, and with pi4 as the dependent pi term. Now during this formulation of RSM model or a 3D mapping, we have to get the product of pi1 and pi2 and pi3 for every observation. And then a graph has to be plotted between pi1, pi2 on x-axis, pi2, pi3 on y-axis and pi4 on z-axis. So supposing we have all the 40 observations, 40 sets of observations, then the entire set of observations can be plotted three-dimensionally in terms of 40 points in the space. And these 40 points only accidentally would be conforming to one fine thread or string, which will of course conform to a space curve. And then the equation of the space curve will be the mathematical model of that activity or of that phenomena. However, this will rarely happen, but alternatively all 40 points would be tangential to one curved surface. The equation for this curved surface will be the model of our activity, model of our phenomena. So in short, we can say that modeling is to identify the real world problem. This is done to, we can identify the real world problem by performing the background research. So we have to focus on a workable problem. We can conduct the investigations in the laboratories if it is possible, if it is appropriate. We can learn the use of computational tools like Matlab, Mathematica, MS Excel or Java. So we have to understand the current activity, and using the mathematical model, we can predict the future behavior of that activity. One more thing, one more possibility of the model is by the technique of artificial neural network. You might you might have heard about the artificial neural network. And the approach to this study is already, it has not been discussed in this lecture, but it has to be discussed separately. So, ANN approach of modeling is also a very good approach, and we can get very good data or very good model based on ANN activity. So we can say that modeling is to express the working model in mathematical terms, write down mathematical equations whose solution describes the working model, and in general, the success of a mathematical model depends on how easy it is to use and how accurately it predicts. If you get a very complicated model involving highly, more or very more number of the independent terms or the variables, and the result is very complicated, the predictions you get is not that accurate, then we can say that the model is, or the mathematical form for that activity or phenomena is not that successful. So we can say that experimental scientists are very good at taking apart the real world and studying small components. It's like since the real world is a non-linear one, fitting the components together is a much harder puzzle. And mathematical modeling, it allows us to do just that. So ideally, the combination of science and modeling, it leads to complete understanding of the activity or the phenomena which is being studied. So not only the experimentation part, but the modeling part also is very much important. And in science, in chemistry or in physics, in mathematics, in chemistry or physics basically, we don't use this mathematical modeling form of for a chemical reaction or for, this work has not been done earlier or not been discussed in earlier cases. So this can also be, we can also introduce this type of work in our research. As we have done, we have completed our research, but still we can use this type of procedure for our, for the research work of our students, or we can guide them to do this kind of, or use of mathematical modeling, and its application to our chemistry or physics. This is the only thing that I would all I have to discuss in this session. These are the references that I have used. Theory of Engineering Experimentation is the book of McGraw-Hill Incorporation by H. Cheng Jr. And the entire procedure which has been followed for formulating a mathematical model in this particular approach is for Theory of Engineering Experimentation by H. Cheng Jr. Thank you all, everyone, for listening to me patiently. Thank you so much.
Thank you so much, ma'am, for taking out time for this program and sharing your knowledge with us. The panel is open for discussion.
Manisha madam, I think one of the participant has
Yes,
raised the
madam.
hand. What's the name of the participant? Vaishali.
Vaishali Duaskar.
Hmm. Vaishali Doraskar madam, are you there? You raised the hand. Is there anyone else having any questions regarding the session?
Ma'am, my question is, in whatever we can draw the different types of graphs by taking
Not clearly audible, Vaishali ma'am?
Yes, ma'am.
Vaishali ma'am, you are not clearly audible.
In what way we can draw different graphs, ma'am, with the help of the. Hello, ma'am. Yeah.
Ma'am, can you repeat the question? It's not audible clearly.
Or write in the comment. Write in the comment
Okay,
box.
okay, ma'am. I'll write in comment box.
Or you can have my number, Vaishali ma'am. We can discuss personally. If you have any query. Hardas ma'am, will that do?
Yeah. Yeah, sure.
I mean, she can get my number from you if possible, and then
Yeah.
I can discuss with her personally.
Okay, okay.
Okay, ma'am. Okay.
Thank you very much,
Yeah.
ma'am,
Okay, thank you, Vaishali
for
ma'am.
taking out time for this session and taking it, comparing it with real world questions and discussing it. Thank you very much, ma'am.
Thank you so much. Thank you, ma'am.
Thank you,
Thank you,
Manisha ma'am. It
Manisha,
was a
madam.
very informative session.
And very useful too.
Thank you, sir. So much, ma'am. Thank you so much.
I also thank all the participants for their patience from the very beginning. Here we complete our day 2 of STTP. Feedback forms will be provided for today's session. I request all of the participants to please fill the form. For tomorrow's session, I request all of you to join at 10:50 a.m. Thank you, everyone.
Okay, thank you everyone for joining. सर्वज्ञ ना, you can close the YouTube live and as well as meeting भी बंद कर दो. सर्वज्ञ अरुण.